Welcome to the lecture on confidence intervals and proportions. A proportion is a fraction, ratio, or percentage indicating the part of the sample of the proportion having a particular trait of interest. For example, we might be looking at Baylor football or Baylor students, and we say 80% of the Baylor student body is a fan of the football team, which would mean that 20% is not. So that would be a proportion, and it's an either or. It's either you are or you are not, which is very familiar to something else that we've worked with in the past. A proportion is calculated by, first of all, a proportion is represented by P, is found by X, the number of successes, divided by N, the number of observations. So number of successes divided by the number of observations, this is the same exact formula that we used for probability for doing the binomial probability distribution. So an example of this is, like, for instance, the Southern Tech Career Services report that 80% of its graduates enter the job market in a position related to their field of study. Okay, so 80% do, 20% don't. So the proportion would be 0.8. We don't know the number of observations. We don't know the number of successes. All that we know is the proportion here. Same thing here, a recent study of married men between ages 35 to 50, so that's the population, found that 63% of both partners felt that 63% of both partners should earn a living. So we don't know the number surveyed or the number that said yes, but we do know the proportion. The proportion is 63. Okay, so confidence intervals. A proportion proportion is identified by pi. So two requirements. And remember, pi we also used in the binomial probability distribution. So everything that we're doing here, just think of it as the binomial probability distribution. It's the same requirements, a lot of the same stuff. So the binomial conditions have been met. The value of, in order for us to use this, the value of n times pi and n multiplied by 1 minus pi should both be greater than or equal to 1. Okay, so let's take a look at this for a second. Okay, so if we have prior, what is pi? Pi is 0.8, and then we also have n, or pi, or p. 1 minus p is whoops, I don't know what just happened there. 0.2. Okay, so in order to keep on going, n multiplied by 0.8 and n multiplied by 0.2, each one of those separately needs to equal 5 or more. So the way that we can calculate the number of observations required, we do 5 equals 5 divided by the smaller of the two numbers. So the minimum number of observations that we need in order to be able to calculate this is 25. However, the greater number of observations, the better job that we're going to be doing at calculating this. Okay, so we need a minimum of 25 observations. Okay, and so we construct a confidence interval for a population proportion with the following formula. Okay, so let's take a look at this based on the data from the previous slide. We've got P, so P is equals 0.8. Before we do that, let's just calculate the margin of error. Remember, the margin of error is z, and then the square root of this. So this is the margin of error for the confidence interval for a population proportion. Okay, so we've got the z-score, and we're going to use a z-score of 1.96 equals 1.96, and the reason why we're using that z-score is because that z-score reflects a 95% confidence interval, and if you look at the z-distribution, you look at 47.5, multiply that by 2, so 47.5 or 0.475, the corresponding z-score is 1.96. So just know that over and over and over again, for a z-score for calculating a 95% confidence interval, it's 1.96, and that's just a number that you need to know. Okay, so 1.96 multiplied by the square root of 0.8 multiplied by 0.2 divided by n. N doesn't work, divided by 25. Okay, so 0.8 times 0.2 divided by 25, and we're taking the square root of that, and we're multiplying that by 1.96. So that gives us a margin of error of 0.1568. So we've got, we're going to calculate the confidence interval limits. So right here we have 0.8 equals 0.8 minus 0.1568, and then we have equals 0.8 plus 0.1568. So these are the limits, 0.6432 and 0.9568. So based on the previous example, let me pull the previous example back up. We have a Southern Tech Career Service report that 80% of its graduates enter the job market in a position related to their field of study. So if I calculated this statistic based off of a sample of 25 individuals, and the mean was 0.8, I would basically be able to say that I am 95% confident that between 64.32 to 95.68% of individuals that graduate from Southern Tech get a job in their position in their related field of study. And in my opinion, this is a really poor statistic. If I were to go in to my boss and I were to say, hey, based on my research, based on pulling a few people, between 64% and 95.6% of individuals get a job in their chosen field, he would tell me to go back out and become a little bit more confident, or to decrease my confidence interval. And so ways to decrease the confidence interval, number one thing that I could do is I could decrease the confidence. I could go from 95 to 90. If I were to go from 95 to 90, let's see here. Let's pull up the z-score chart. I'll pull this up really quick. Unit 2. Okay, if I were to use a 90% confidence interval, we're going to find 4,500. So we've got 45, 44. So, this is the wrong one, sorry. We want the unit 3. Formulas, t-distribution, there we go, this is what we want. So we want to find 4,500 under the area of the normal curve, which is basically right here. And so 0.05, and we find the corresponding over here, so it's 1.65. So we put in 1.65 in the formula instead. Okay, and so it decreases it a little bit. So 1.65, you have a 90% confidence that between 0.668 and 0.93 percent of individuals get a job in their chosen field. So that's one way to do it. Or the other way to do it is to drastically increase, or just subtly increase the number of individuals in your observation, okay, in your sample. So let's look at the next page. So the union representing the Bottle Blowers of America, BBA, is considering a proposal to merge with Teamsters Union. At least 3/4 of the BBA membership must approve of any merger. A random sample of 2,000 current members reveals 1,600 plan to vote for the merger proposal. What is the estimate of the population proportion? Can you conclude that the necessary proportion of BBA members favor the merger, and why? So the first thing that we need to do is calculate the proportion, right? So we have the number of successes. The number of successes is, we come right here, 1,600. The number of observations, 2,000. So 2,000 people were polled. 1,600 said that they were going to vote for the merger. Okay, so 1,600 divided by 2,000 is 0.8. So this is just like the one previously, right? So the next, we use formula 9.4 to determine the 95% confidence interval. We have P, which is 0.8, plus or minus Z, so 1.96. And then we have the square root of P multiplied by 1 minus 2, so we have 0.8 multiplied by 0.2 divided by 2,000. And then you take the square root of that, which gives us 0.8 plus or minus 0.018. So the margin of error here is 0.018. Remember the margin of error that we had in our previous problem? The margin of error was 0.1568. Now there is a huge difference between 0.1568 and 0.018, and that whole difference is solely summed up, or the whole difference between those two is just because we increased from 25 people to 2,000 people. So because of that now, the limits of the confidence interval are 0.782 and 0.818, where previously, in the previous problem, the limits were 0.6432, and then also 0.9568. So just because we surveyed 2,000 people, we were able to decrease the range, or we were able to make the confidence interval smaller to say we are 95% confident that between 0.782 and 818 percentage of individuals are going to vote for the Bottle Blowers of America for the merger. Another way to say this is if we were to take this survey of 2,000, if we were to take this 1,000 times, redo this survey 1,000 times, we are 950 of those times the mean would be captured within that survey results, and we'll get into that a little bit later. That's a little bit more than what I want to talk about right now. But if I were to redo this survey 1,000 times, 950 of those times it would capture the mean within its range. So that's the end of the confidence interval for proportions. Make sure that you know how to do that formula and to calculate also the number required for the minimum number to be able to calculate this. Alrighty.